Hello everybody, welcome back to another video, and in this video we'll be looking at an integral from the Stanford Math Tournament calculus section from the year 2022. And this is a pretty interesting problem because the function part itself is a well-known integral on its own in the indefinite case, and now we have some bounds to work with, so this is going to be pretty cool. So first of all, how do we integrate this sine of the square root of x? Well, what we can do is we can perform a u substitution where we say that u is equal to the square root of x. And when we say that u is the square root of x, we can see that now squaring both sides, x is u squared. Now you can simply take dx on both sides, so dx ddx on both sides, so dx is derivative of u squared is of course 2u, and then you have a du here. And now we need to consider our bounds, our limits of integration. So since we said u to be the square root of x, our lower bound now, our new integral, will be the square root of 4 pi squared. And we see that here very nicely, these are a product of two functions. So what we have here is we just have a 2 pi, because the square pi squared will cancel and the square root of 4 is 2. Now we also have to take the square root of pi squared over 4. Now we know that we can just separate the roots and see that's the square root of pi squared over the square root of 4, which is just going to be pi over 2. So now we have the integral from pi over 2 to 2 pi of now the sine of square root of x. Well, the square root of x is our u, so we can put our u here. And our dx is 2u du. So why don't we also take that 2 out, so we have a 2 here. And now we just have a u du. So how do we integrate this? Well, we have a product of two functions. We see that here we have, in fact, a polynomial of degree 1. So what you can do, you can just use integration by parts, and we see that this will be a pretty easy integration by parts, because when we said u to be what we differentiate, we put a plus minus here. We see that here we get a 1, differentiating u we get 1, and of course differentiating u in the u world, then differentiating any constant you get 0. So once you get a 0, we stop. And now we are integrating the sine of u, as that's the other function as part of the integrand. Now integrating the sine of u, well, we know that's the negative cosine of u, negative cosine of u. And now integrating the negative cosine of u, well, we know that the integral of cosine of u is sine of u. However, we have a negative there, so this is going to be the negative sine of u. Now, as we reached the 0 in one of the columns, namely the differentiating column, all we need to do to get the answer is just to take the product of these diagonals, and that is, in fact, our final answer. So what we have now is that what we have, okay, let's just see what we have here. So we have 2, and here we have u times negative cosine of u. So we have negative u cosine u. And then here we have a negative 1 multiplied by a negative sine of u. So that negative and negative is going to become a positive. So we have a plus sine of u. And guess what? This is all being evaluated from, so let's just first distribute the 2. So this is being evaluated from pi over 2 to 2 pi. Now what we have here is we have negative 2u cosine of u plus 2 sine of u from pi over 2 to 2 pi. And I'm just going to double check if we made any mistakes. So what we did use the square root of x. Now we found x is to be u squared, and we fixed the limits of integration. We performed a integration by parts here. Let's just mention it, and then we get this. So what we need to do now is we just need to use the fundamental theorem of calculus, which is where we plug in the upper bound and subtract plugging in the lower bound. So what we have as our answer is negative 2 multiplied by a 2 pi times the cosine of u, which is 2 pi now. And let's say that this 2 pi is outlined in this color, so it's more clear. So here we have a 2 pi. Then we add 2 sine of, and then 2 pi. Now that is the first part of our answer. Now we can put a bracket around everything, because now we have to subtract, and then plugging in a now pi over 2. So we have negative 2 multiplied by a, now let's say this color is going to be the pi over 2. So this is 2 times pi over 2 cosine of, but that cosine is not meant to be like that. The cosine is like this. And we have the cosine of pi over 2 and then we add 2 times the sine of u, which is pi over 2. So this is our final answer. However, we can definitely do some simplification here, because the first thing that we notice is that the cosine of 2 pi is 1, and the sine of 2 pi is 0. That is just something we should know because of the periodicity of these two functions. So therefore, these are equivalent to the cosine of 0 and the sine of 0. The sine of 0 collapses to 0, and the cosine of 0 collapses to 1. So this is equal to negative 2 times, and then we have a 2 pi. Let's just keep the bracket here as well. And then times 1, because that cosine of 2 pi evaluated to 1, then we see that we just have to add something multiplied by 0, because sine of 2 pi is 0. So that term will cancel out. So we don't need to worry about any of that. Now, all we need to do is we need to subtract negative 2 times, now we have a pi over 2, and we know that the cosine of pi over 2 is in fact 0, and we know that the sine of pi over 2 is indeed equal to 1. Those are also some things that we should know, because the sine graph, we know the sine graph goes like this, where this point here is pi over 2. So we would see that this is 1, and the cosine graph is just a shifted sine graph where we start from here. So now we see that where this point is pi over 2, this is 0. So now going back, we see that we have something that is being multiplied by 0. So this entire term will just cancel out. And now we have 2 multiplied by sine pi over 2. So that is equal to 2 multiplied by 1. And multiplied by with this one, like so. So finally, we have, just writing everything in the same color, we have negative 4 pi minus 2. And I believe that this should be our final answer, because there are no further simplifications there. So I just checked, and this is indeed the correct answer. So we can put 2 ticks here and say that we are done. So if you ever come across an integral like this on the Stanford Math Tournament, you know what to do. You know that you have to use your u substitution and then your integration by parts, and just know your sine and cosine angles, as those are very helpful with competition math questions. So that was it. Now, the second integral we'll be looking at is from the calculus tiebreaker of the Stanford Math Tournament, of course. And this integral is a pretty simple integral. However, you have only 15 minutes for this test and 3 calculus questions. So this is really a test of your speed. So let's try and do this really quickly. And I often do these problems as soon as I see them without even attempting them first. So there's bound to be some mistakes here, but let's see if I can speed run this pretty effectively. So we have a lot of x minus 5s, and we can see that they're going in sums of ascending powers. So the first thing we can do, we can expand the brackets. No, absolutely not, because what we can do is we can take a u sub. Set u to be x minus 5, therefore taking du, we see that du is just going to be equal to dx. That's nice. Now our limits of integration, well, we said u to be x minus 5. So now we're going to have the integral from 0 minus 5, which is negative 5, and then 10 minus 5, which is 5, of x minus 5, which is our u. And then we have our x minus 5 squared, which is u squared. Then we have u cubed and du. And of course, this is going to evaluate to u squared over 2 plus u cubed over 3 plus u to the 4th over 4. And that's being evaluated from negative 5 to 5. So what we see here, we have let's plug in the upper bound. So we have 25 over 2 plus 125 over 3 plus, 625, I believe, over 4. And that's in a bracket, and then you subtract. This is a negative 5, just to make it more clear. Here, negative 5 squared, that's cool. That's also 25 over 2. Then negative 5 cubed, that's negative. Oh, wait, so that's going to be a negative 125 over 3. And then to the power 4, that's going to make it a positive 625 over 4. I see where this is going. What we see is that this, when the negative is distributed, this and this and this and this will cancel. And we're just left with 2, because a negative of 125, which is 250 over 3. So this should be the answer. That was a pretty cool speed run. So that was it for today's video. I think this would be the last integral that I look at. So thank you for watching.